Okay, we are here to discuss one version of quiz number 5 we have had last Wednesday. We had different versions and the topology were actually almost the same, but the concept was a bit different from one to another. Take a look at this. I have all the resistors, and all the resistors are given to be 1 ohm. All the capacitors are given to be 1 farad, and inductors are given to be 1 Henry. And the voltage of interest is the voltage across the middleman, which is the 1 ohm. Now, I take a look at this design and I see everything is actually in time domain. Okay. As we said, we are going to capture the frequency, and in this case, the frequency can be captured in radian per second. Okay. Because when I take this to the frequency domain, I don't have to carry the 2t with me all the time. I'm conscious to see that this is 2t and this is 2t at the same time, so the frequencies are the same. So that's good news actually. I'm going to take this into the time domain. I'm going to solve this using Nodal. I'm going to solve this using mesh. And the two answers should be the same because the system is actually linear. And that should be a blessing in the sense to basically do a self-assessment right at the same time of the exam. Let's go one at a time. That's the voltage source, fine. That's the plus cosine function. That's what I need to see. The coefficient is positive, the shape itself is a cosine function, so it's going to be 1 angle 0, because there is no theta. The theta is 0, the phase shift is 0. 1 angle 0. This is 1 e to the power of j0. E to the power of 0, it's 1. So basically, you can also basically see a unity circle in front of you. And if you see a unity circle in front of you, you would see this is going to be plus 1, this is going to be plus j, this is minus 1, this is minus j. So that's what I'm going to see. If I say 0, it means 0 angle. The 0 angle gives me plus 1, or e to the power of 0 anyway is 1. And the result is going to be 1. So this one is going to be a simple 1, and that's not DC though. It's in frequency domain. That's why it could be misleading. This one is simply 1. If it's not cosine, you have to make sure it's cosine. If the coefficient is negative, you have to make sure the coefficient becomes positive. The resistor is going to be the same. So this resistor is going to be the same. The voltage is going to be capital VO now. That was a small VO, this is capital VO. This resistor is going to be the same. This voltage source is going to be, to have a bit of a phase shift. The phase shift is 45 degrees. The value, the amplitude is 1, the shape of the function is cosine, so it's going to be 1 angle 45. You don't have to change this. Just leave it as it is. You don't have to make this Cartesian, for example. So this one is, just keep it like this, but I know what this means. This is e to the power of j 45 degrees. If I wanted to take this to the Cartesian, of course the calculator has the option of doing that, but also I can say a Euler function is cosine 45 degrees plus j sine of 45 degrees. You don't have to do this. If you do this, you're losing time. And that's a precious time you need to avoid losing during the exam. So let's go back in. I'm going to actually erase this, leave this in the phasor form or polar form. The capacitor, I need to be careful. It's 1 over C omega j. C is 1 farad, omega is 2, and that's j. So what do I say? 1 over 2 is 0.5. 1 over j is minus j. So it's minus 0.5 j. Minus 0.5 j. Okay. How much is my inductor? My inductor, the formula is L omega j. L is 1, omega is 2, j. This is going to give me 2j. And there is nothing else underneath. So I'm going to erase this to make a space for my calculation. The underneath is actually just connected. Okay. Let's solve this using Nodal first. Well, the rule of thumb is take a look at your design, pick up one of the voltage sources, and the negative pin of that voltage source, just ground it or make it a reference node. So I'm going to make this reference node. Although I had a focus on this, for example, to have my reference node picked up, I can see that this is the same as this one. Everything under this graph is my reference node. Okay. If this is 0, how much is this? That's going to be 1 volt in complex domain, so that's going to be 1 volt in this node. If this is 0, how much is this? That's going to be 1 angle 45 degrees. That's what it is on this node. I've got 2 voltages of left and right of the design done. What are the unknowns? The unknown is Vx on this and Vy on this. I also know what my game plan is. My game plan is Vo is equal to Vx minus Vy. So if I do Vx minus Vy, I've got myself Vo. I need to do 2 equations to unknown. That's the only unknown I have. So let's do the Vx first. Vx minus 1 volt divided by 1. Vx minus 0 divided by minus 0.5 J. This minus this divided by this minus this divided by this minus this divided by this, plus Vx minus Vy divided by 1 as equal to 0. Now I need to turn my attention to the next node. It's going to be Vy minus this divided by this, Vy minus 0 divided by this, Vy minus this divided by this. I have 3 components attached to this node. I need to have 3 terms. So Vy minus Vx divided by 1, Vy minus 0 divided by 2j, and then Vy minus 1 angle 45 degrees divided by 1 as equal to 0. Okay. I made sure that my equations are written correctly. All I have to do is to extract and build the system. I'm going to have Vx, Vy constant. Vx, Vy constant. So Vx is going to be 1 plus 1 divided by minus 0.5 J plus 1, that's Vx. Then I need to be careful about Vy. It's going to be minus 1, and I don't see anything else. And in terms of constant, no constant, no constant. This is the constant that goes in, and that would be 1. Let's take a look at this equation. I'm going to have Vx. It's going to be minus 1, and that's it. Okay. And then I'm going to have Vy. I'm going to have 1 over 2j plus 1. And what is my constant? The constant is only this one, 1 angle 45 degrees. As soon as you build the design, you can apply the Kramer rule, and as you can see, I have not simplified anything. I'm not trying to apply the steps manually by myself. So what is my system? My system is 1, you can do a minor modification. 1 plus 1 is 2. 2, that's going to be, you can bring the minus sign on top, minus 1 over 0.5j. You can even leave this like this, that's fine. So minus 1 is fine. Minus 1, I have it. 1 and 1 is 2 plus 1 over 2j. You can always say 1 over j is minus 1 and have it in better shape. Delta x, delta Vx, how much that is? You remember that this column, this is going to be the column, the terms responding to Vx. I need to remove these components and replace it with the right-hand side. So that's going to be 1 angle 45 degrees. This is going to be minus 1, and it's going to be 2 plus 1 over 2j. I'm looking at top. That's my delta Vx. What is my delta Vy? I'm going to have this system, but the second column is now replaced with the right-hand side. 2 minus 1 divided by 0.5j, minus 1 remains intact. This one is going to be replaced. 1 angle 45 degrees. Because I'm short of a space, I'm going to actually eliminate this for now. Okay. Obviously, you have access to the white pages on your exam. Let's take a look at this. This is me. It's diagonal minus antidiagonal. Diagonal, antidiagonal, diagonal, antidiagonal. So that applies all the time. Let's see if we can get this right. Well, I turn this on, even though it's in the exam, it might be off for a time, but when you turn it on, it's still in complex domain. So I'm going to open bracket, 2 minus 1 divided by open bracket. 0.5j has to be inside bracket. So keep that in mind. 0.5j, that's one possible source of mistakes. Okay, so I have a big bracket, 2 minus 1 divided by the bracket 0.5j, and a closed bracket for the entire design, and then multiplied by the big bracket once again, 2 plus 1 divided by the 2j itself is going to be inside the bracket, so I need to be careful. Close bracket minus open bracket, you have minus 1 times minus 1. Okay, nice and clean. That's 4. Go shift equal sign, it's going to be plus 3j. Very simple. Let's see if we get this one. And you see I have a polar representation. I'm not going to be worried about it. I'm just going to use the calculator to do the job for me. Well, 1 times this is going to be this one, right? So it's going to be 2 plus 1 divided by 2j. Remember, 2j is going to be inside the bracket, minus open bracket, minus 1 on top, times, this is 1 angle. Again, angle is actually shown on this minus sign. So it's going to be angle, and it is set into degree mode, and that's it. And it's pushing equal sign, and you get yourself 2.707, and then when you say shift equal sign, you get minus 0.207 J. Let's go for this one. This one is going to be open big bracket, 2 minus 1 divided by a smaller bracket, 0.5j. This 0.5j has to be inside bracket. Keep that in mind. Otherwise, you're going to lose it. Close the big bracket times 1 angle 45 degrees. Even 1 angle 45 degrees, I'm going to put it inside the bracket. Little steps are going to actually save you a lot of headache. Shift angle 45. That's this. Minus 1 times minus 1 is minus 1. So it's actually plus 1. So what do I get? It's going to be 1. Shift equal sign is going to be plus 2.828J.
That's supposed to be plus 1.07. The Vx.
This one?
Yeah.
Okay, let me just see what the mistake is. It's going to be 2 plus 1 divided by 2j. You have minus minus, so that's plus 1 angle 45 degrees. That's right, and then this, you are absolutely right. Thank you. So basically, we got the determinant of the system, we got delta Vx, and we got delta Vy. So I need to find Vx. and I need to find Vy. Vx is delta Vx divided by delta. Vy is delta Vy divided by delta. So let's see. Delta Vx divided by delta, that's going to be Vx. It's going to be 2.707 plus 0.207 J divided by 4 plus 3 J. Vy is going to be 1 plus 2.828 J divided by 4 plus 3 J. Let's go and use that. And remember, utilize the bracket as much as you can, and that's going to save you a lot of headache. And unless you have made a copy here and there from the calculator to the board or from the board to the board, there is not much of a human intervention in the process, as you can see. So I'm going to say open big bracket 2.707 plus 0.207 J, I remember the J, then divided by, close the bracket, divided by, so you have the entire thing in bracket. This has to be in bracket, this has to be in bracket, this one in bracket, this one in bracket. You need to make sure on the calculator you don't forget the brackets, otherwise you're going to be in deep trouble. So it's going to be 4 plus 3J. So this one is going to be 0.458, the real part, and it's going to be minus 0.292J. Let's see what happens on this side. This one is open big bracket, 2 plus 2.828J divided by 4 plus 3J, close bracket. So this is 0.5 almost, and this is plus 0.333J. Oh, doesn't matter, cut it out. Okay, I've got myself Vx, I've got myself Vy, and I want to find Vo. Vo is Vx minus Vy. Again, even though it is a subtraction, I do suggest you put them in the bracket. 0.458 minus 0.292J. Then you have a minus, open bracket, remember that, this is a minus sign, and it's going to apply to the entire number you have. That's why I'm saying utilize, be a friend to brackets. 0.5 plus 0.333 J and close bracket, give me the result, minus 0.042, and then shift equal sign, minus 0.625 J. I'm going to keep an eye on this. That's a nodal, and I want to see if I get the same answer when I do it in mesh. Okay, let me clean my stuff because I need a space. This one. Okay. 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 So what do I have? In terms of mesh, when I ask you to do mesh, typically I would not expect you to do source transformation. I don't want you to do source transformation and shrink. Source transformation and shrink, because for source transformation we have a different question all the time. We attack it differently. So I need to identify my basic loops. Well, that's 1, I'm going to call this I1, that's 2, I'm going to call this I2, that's 3, I'm going to call this I3. Basic loops. Well, I don't see any current source. If I did, I need to check to see if that current source has been touched twice by 2 different loops. But at this time, I have no current source and 3 loops. I am anxious because I'm going to see 3 equations, 3 unknown. That's the price I'm going to pay. But there is a good news on this side. VO is the voltage across the 1 ohm. And if I know what I2 is, I2 goes into 1 ohm, so 1 times I2 is my VO. So although I have a 3 by 3 system, I really don't need to find all the determinants. All I need to find is the determinant corresponding to I2 divided by the determinant of the system. Let me write down the equation and then refresh your memory on the calculation of a 3 by 3 system. Let's take a look. That's going to be minus 1. I'm starting from here. Now we know what to do. Plus 1 times I1 plus minus 0.5J times I1 is in and I2 is opposing. I1 is the master, I2 is the slave, and opposing is equal to 0. That's this loop. Take a look at this and let's start from this point. It's going to be minus 0.5J. Again, I'm trying to utilize the bracket as much as I can. It's going to be I2 minus I1. I2 is this, I1 is opposing, I2 is the master, I1 is a slave, because my loop is this one. So that's going to be this, and then I'm going to have 1 times I2, and then I'm going to have 2J. Let's put that in the bracket once again. I2, I3. If we assign them clockwise, most of the time they are going to oppose each other, unless I have changed my loop due to the super mesh concept. Let's go to the last one. Let's start from this point, for example. It's going to be 1 angle 45 plus 2J. This time the master is I3, the slave is I2, and obviously they are opposing each other. And then I'm going to have plus 1 times I3 as equal to 0. I don't have a space, so I'm going to erase a bit of a circuit, but you can actually double check to see if yours, you wrote the equations correctly. Yep. Okay. So I want to have I1, I2, I3 constant. I1, I2, I3 constant. I1, I2, I3 constant. That's the way I build my system. So it's going to be I1 times 1, and then I have minus 0.5J. And then for I2, I have a minus minus. I can do this much of modification if I wanted to. 0.5J I2. Don't go too much. And since this loop doesn't share anything with I3, I can imagine there is no I3 in that first equation. Plus 0 I3 as equal to minus 1 goes to the other end, is going to be plus 1. I need to maintain the same steps, the same organization. So it's going to be I1. I'm going to have minus minus. I can do this much of simplification, no harm. Do I have anything else? No. Then I'm going to have I2. I2. I have 1. I have minus 0.5J. I have 2J. 1 minus 0.5J and 2J. Okay. And then I'm going to have plus minus 2J I3 as equal to. Because this loop does not have a voltage source, I can imagine the constant is going to be 0. Okay, now let's take a look at this one. I know that this loop is not interacting with this, so I'm not surprised that it doesn't have anything with I1. Let's take a look at I2. I2, I only have minus 2J so far. And I3 is going to be 1 plus 2J. And the right hand side is going to be minus 1 angle 45. I hope I don't forget the minus because it's a bit too small. So it's minus 1 angle 45. Also, in linear circuits, one of the interesting things that could happen easily is a symmetric response. Minus 2J, minus 2J. Plus half J, plus half J. 0, 0. It's a matrix which is symmetric along the diagonal component. That's fine. You can always double check to make sure everything is fine. Okay, so what's my system? My delta, which is the system determinant, is going to be 1 minus 0.5j, 0.5j, 0. 0.5j. Slightly you can do this, you don't have to. 2 minus half is 1.5, so it's 1 plus 1.5j, and then minus 2j. It's going to be 0, minus 2j, 1 plus 2j, that's the system determinant. You can see the symmetric behavior, this one, and this one. I need to erase the circuit. I hope I haven't made any mistake. If I did, I can easily go back and check that. Okay. Now, as I said, looking at that design, which I just erased it, the voltage across the 1 ohm would be 1 ohm times the current that goes in, and I only need to find I2. So all I need is delta I2. Delta I2 requires me to copy the system determinant here, except that the column that represents I2 is placed with the right-hand side. So I'm going to have this one, and this one the same, and the second column is actually replaced by 1, 0, minus 1 angle 45 degrees. Again, I hope I haven't made any mistake. And then, of course, I2 would be delta I2 divided by delta. Now, if you remember, in terms of finding the determinant of a 3x3 system, all I need is this. I need you to copy the first 2 columns and duplicate it on this side. Paste it on this side. 1 minus 0.5j. 0.5j and 0. 0.5j, 1 plus 1.5j, and minus 2j. Then I need you to focus on diagonal component. So this is diagonal. 1, 2, 3. You need to multiply them, you need to sum them up, and that's going to be the diagonal conclusion. Then I need you to go and do anti-diagonal. This, this, and this. You need to sum up all the anti-diagonal as one element. Diagonal minus the anti-diagonal, that would be your response. So I want to go slowly. Let me do this on this part. Just the diagonal for now. It's 1 minus 0.5j. 1 plus 1.5j. 1 plus 2j. This I'm happy because this 0 is going to give me 0. This 0 is going to give me 0, fine. But if they are not 0, all I have to do is just to write it down. Plus this, plus this. All the diagonal components are going to be summed up. I'm going to put them inside the bracket. Minus. The anti-diagonal are supposed to be summed up. So I need you to sum up the anti-diagonal. This, this, and this. I'm happy with this because this is 0. So I have 2 terms to write. 0.5j, 0.5j, 1 plus 2j, and then I'm summing up. I have a minus sign behind the entire bracket. It's 1 minus 0.5j, minus 2j, and I just don't have a space, multiplied by minus 2j again, and then the entire bracket is closed because the last term is 0. So I need to calculate each one of them individually and then subtract. So why don't we do that? Well, remember the brackets. 1 minus half j, 1 plus 1.5j, 1 plus 2j. Okay, I'm going to actually continue. As long as I know this minus sign is going to be behind this and behind this, I'm going to be fine. Minus, open bracket, 0.5j, 0.5j, 1 plus 2j. Again, minus plus is minus, so I remember that minus sign. 1 minus half j minus 2j. In each one of them, I'm going to put them inside the bracket. So that's perhaps the reason I would be successful at the end. Okay. This is equal to 4. And then shift equal sign is 3 plus 3j. That's a similar number. That's a good number. This is a number we saw just in the nodal equation. So that should give me a comforting sense that I might be right. I might be correct. So let's take a look at this one. So I'm going to write it down. The first determinant was 4 plus 3j. Okay. Okay, one more time. You just need to copy and paste. Copy the first two columns. 1 minus 0.5j, 0.5j, 0, 1, 0, minus 1 angle 45. Okay. Give me the diagonal. 0. Nice. 0. Very nice. 0. Good. The diagonal is 0. So the diagonal is 0 minus, don't forget this minus sign. Open bracket. Anti-diagonal, this is 0, which is not bad. So I have two components to write. So it's 1 times 0.5j inside bracket times 1 plus 2j inside bracket. That's this. Plus, remember this minus is going to be applicable on this one. Plus 1 minus 0.5j times minus 2j times minus 1 angle 45 degrees. Close the big bracket. Okay. So I'm going to say, actually I'm going to just do 0, 0, exactly 0, minus. And I know that this minus is going to apply to this, and then when it comes to the second term, that minus is going to come in. So I have two minuses in mind. You can do that. Well, however technique you feel comfortable, do it. But remember the brackets. 1 times that. 1 times is crazy. So it's 0.5j times 1 plus 2j. That's the first term, minus, because I brought that minus sign inside. Open bracket, 1 minus half j minus 2j. And then the last one, I'm going to put it in a bracket, but I'm going to use the polar representation. So it's minus 1 angle 45 closed. Yes. Oops, I think I forgot one of the brackets. One more time. I've got 0 minus, open bracket, 0.5i, 1 plus 2i, and then you have another minus sign, open bracket, hopefully I don't forget the brackets, times minus 2j, okay, times 45 degrees. Oh, I have a feeling, I tell you what happened, 1.707, that's a familiar number, and then shift equal sign, minus 2.621j. Let me see if I get the numbers and I get back to you on this process. Just a minute ago we did. So I need to find 1 times I2, and I2 is delta I2 divided by delta. So all I have to do is to get this one divided by this. So let's divide, answer 4 plus 3j. Nice! It's minus 0.04142, and then shift equal sign, minus 0.62426j. Don't go this far. I only need 2 digits. 2 digits, 3 digits maximum. You're going to have some rounding error. Just be ready to expect that kind of a rounding error, but that's all that. Now, what happened when I did the first time, calculator does not accept a negative polar value. So when you want to say minus 1 angle 45, you should say 0 minus 1 angle 45. Minus 1 angle 45 doesn't seem to be getting you the answer, right? It works on yours. But just in case, if it does work on your calculator, just make sure. How come? Minus 1 angle 45. Mine gives me a math error. Minus 1 angle 45 doesn't give you the right answer. You need to make sure your calculator is actually the approved one.
This is
So make sure that's, so if you have minus 1 angle 45, this calculator, which is a approved Casio, doesn't accept that. You have to say 0 minus 1 angle 45. That's what happened. Okay. Let's end this session with a smile. What we are going to have later on, I'm going to have 2 more recording sessions. One is going to be on the dependent source, and another one is going to be on the AC power. But hopefully everybody knows how to handle those as well. So thank you very much. I appreciate the help, and see you later.